dealing with finding the right position of A of j in A of I to j. A subarray of A, given that A of I to j minus 1 is already sorted. We can see green color sprinkled over the sorted part of A of I to j, that is A of I to j minus 1. We are worried about the red one, that is A of j. The phrase right position here means the position in which A of j should be placed in the A of I to j, so that A of I to j is a sorted array. Let us store the value of A of j in a variable named x. So we write x is updated by A of j. And how do we use this x? We compare x with A of j minus 1 first. And if x is lesser, we again move left and compare it with A of j minus 2, and so on, if x goes on being found out lesser. And somewhere if we find an index p such that A of p is actually lesser than x, then we have to place x at the position right of that index. So we have to put x at p plus 1. This is the right position. This is the right position of A of j. So we can write different comparisons like this. Is x less than A of j minus 1? Is x less than A of j minus 2? And so on. And somewhere in between we will get, is x less than A of j minus k? And at last we will get, is x less than A of j minus that box we always take. So now we can find the value of this box. This j minus that box must equal to I, because this is the last index whose element we will be comparing with x. So we can write I is equal to j minus that box. From here we can get the value of box as j minus I. So now we can get the variation of k. K varies from 1 to j minus I. Now we proceed in writing the algorithm. We initialize k by 1. After initializing k, we can write a while loop for all these comparisons. So we write while k is less than or equal to j minus I and x is less than A of j minus k. And if this is the condition, we have to keep moving left. For keep moving left, we have to increment k. So we write k is updated by k plus 1. Now when we come out of this loop, we have actually found p, and our answer is p plus 1. The index that we are searching is p plus 1. So what is the index that we have when we come out of this while loop? It is actually j minus k. So our index that we were searching for is j minus k plus 1. This is for p and 1 for this one. So this is the algorithm that we were looking for, and we have to find this index, which is the right position of a of j in a of I to j if a of I to j minus 1 is already sorted.